Welcome back to another MobileSentrix tips and tricks. My name is Derek and today I'm going to be working on this phone. As you can see, it doesn't look very good. The first thing that I think when I see a phone that's this busted is there going to be an underlying issue with the motherboard? One of the classic fails that this iPhone 12 probably experienced is a separation to one degree or another of the top and bottom boards, creating a searching no service, no Wi-Fi, Bluetooth scenario. Given how bad it's broken on the back and the front, it's almost guaranteed to have that issue. I can't tell because of the screen being the way it is. Let's take it apart and see what we can do about it. Man, that has seen better days. It's almost like it got kind of whacked from the back, shattered out the front. It's almost like it's kind of cupped. It's no longer flat. It's been pushed up like that. Got a replacement screen just so we can get it on and see if it's got any other issues. I can see the dot projector wanting to work. If you look very carefully, you can see those flashes. Go ahead and turn it off. The touch still works. Everywhere, the digitizer's still working. That's crazy. And we'll take out the bottom screws. All right, we've got the new screen connected, the battery connected. Let's go ahead and power it on. And when it boots up, we'll see if it has a service. All right, it's really faint because I don't have the proximity sensor connected. But if you can make it out, it does say SOS. With the 4 blinking dots below it. So here, let's do that again. I've got the prox connected. All right, now we're on full brightness, and there at the top you can see it's trying to search SOS. So yeah, we're stuck at this position. Wi-Fi is completely grayed out. Bluetooth is just sitting there thinking. All right, we've got the battery out, and you can almost see there's like a curvature to the board. It's curving ever so slightly. We'll pull out the motherboard. And there, if we look down it, you can almost, it's a little bit more obvious now that there's that bend in it. All right, in preparation for splitting the board, what we're gonna do is add some isopropyl alcohol to all of the sponge protectors for the FVC connectors. And we're going to let the isopropyl alcohol loosen the grip so that we can pull them off. And if you take your time with this, you'll just be able to reapply it easily. If you don't take these off, when the heat gets to them, they'll shrivel. And apart from that just being annoying, it can cause issues. On the back, we've got a sticker that we got to deal with as well. We'll peel that up. To separate the top from the bottom board, you'll need these plates. However, because the rest of the world doesn't have the 5G antenna, I had to grind away the slot there so that I didn't have to desolder it in order to get it to fit. So adjusting your tools, sometimes is required, but that will now work for board separation without having to touch the 5G antenna. And I'm going to screw on this little assistive tool to help remove the motherboard when the time comes. Go ahead and turn it on. And I'm going to select the board and make sure that it's on the 12 Pro Max. We'll turn it on. And we'll let it heat up, and when the time comes, we'll lift it. I'm going to take my tweezers and I'm going to give it little nudges here and there just to see if it starts to move. We don't want to start lifting before we can, otherwise we might pull pads that have been weakened, and I'm assuming we're going to find some pulled pads, so I'm really going to take my time. I'll have about 2 minutes once this fully heats up before it starts to cool down. That's its preset. So we're just going to watch for it to start to move by little taps with the tweezers, and then we'll pull it up. We're almost at temperature now. All right, we are at 250 degrees Celsius. Shouldn't take long. before we start to see movement. I can already see a little bit of bubbling of the flux around the perimeter. See a little bit of movement, but I need to see more. I can see more bubbling. We're a minute down. We have a minute before it starts to cool down. So we got time to lift it up. Wait to the last second to lift it up, and I can see that we got some pulled pads. So we should be able to fix those, and we'll let this just cool down before we start working on it. All right, looking at under the microscope, we've got 1, 2, 3, 4, 5 pulled pads. They're all right there on the inside, kind of where the curve was happening. And looking at the rest of the board, I don't see any other pulled pads. That all looks good. That all looks good. That's good. All right, and there's that first one. Let's take a look at. So here we've got this capacitor turned sideways. So this one right here. So if we look at it, what does it connect to? It connects to the CPU. And what does it correspond with down below? Almost looks like it connects to ground. But we're supposed to get a reading there of 3.4. And then we've got over here in the corner of the CPU. So right here we've got an open line on this side, but that goes over. And would you look at that? That's definitely one of the reasons we don't have service. And then we count 1, 2, 3, 4. Down from there, 1, 2, 3, 4. And then we'll be counting another 4. So here, and then 1, 2, 3, 4. So let's look at this one right here. Again, this one, 1, 2, 3, 4. Open line, and it connects to the CPU. And then coming over here, we've got in the corner, got the ground, and then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So ground, 1, 2, 3, 4, 5, 6, 7, 8, 9. This one connects to the power management. So most likely power is coming through here, traveling through here, through this resistor. All right. It's hard to say exactly what these do without looking at the schematic, but needless to say, it looks like every single one of them we do need to replace. So let's do that. All right, so what we're gonna do is I'm gonna find the right size pad that I wanna use. These ones are perfect. Yeah, I wanna go small on this. And I'm gonna take some 183 solder paste. And we're going to be working with 5 pads today, so I'm going to prep these 5 right here. So the goal is to deposit a little bit of solder on each one of them. Okay. Just like that. 2. I'll add a little bit of flux because I don't like how all of those are. Alright, now we'll just take one of these at a time, carefully peel it up, and we'll transfer it up to the motherboard where it's gonna go. We'll put that one there, come back and grab this one. Grab the third one. Grab the fourth one. And we'll grab the fifth and last one. And we'll put it where it's gonna go. So I'm gonna try to do this without disturbing any of the solder joints around it. We can reball this one if we have to, but I'd prefer not to reball it. And because each one has the correct amount of solder on it with the corresponding side, and it has the spacers that will allow me to compress on it, I'm really going to try to avoid touching the other joints when soldering these on. So what I'm going to do is we'll hold it down with the tip of the scalpel here. And we'll solder that down. Move on to the second one. Go in gently. And we'll solder it on. We'll move over to the next one. Solder it on, move over to the next one. And then move over to the last one, and this one's going to be a little awkward. I don't want to move the clamp, so I'm just going to try to get it from a different angle. Alright, that one's down. Alright, time to clean up the flux. We'll blow it away a little bit. Take a brush to it. There we go. And blow it away. Nice and clean. Move on to the next one and do the same thing. That one looks good. Move on to the next one. That one looks good. Move on to the next one. Really getting out any of the grime. Also making sure that they don't move at all. If there's any movement in the pad, then we'll have to take a look at it one more time, but they don't look like they're going anywhere. So we're gonna go ahead and spray off the alcohol. Make it bone dry. I'm gonna take a little bit of UV mask and we're gonna put a teeny drop on each one. Like that. And then we're gonna get it to kind of go down and cup around. And fill in that little gap. That'll probably do it naturally. Let's see, this one's starting to do it naturally. Help it along there. That's good. This one has a little too much. See if we can get some off. That looks really good. And there we go. So each one has a little bit of UV mask. I'm going to absorb some of that. That was a bit much. There we go. That's better. And this one also has maybe just a touch too much. There we go. Now we'll cure it with the UV light. And while that is curing, let's take a look and see. You can see here we've got the pads that are still on the other board. And then something that you'll notice along this entire edge is you've got a bunch of these grayish looking pads. Okay, that's oxidation. That happens when there's basically, when the solder has access to air, which basically means, and you can see everything else is nice and shiny. We've got the occasional one that's dark, but for the most part everything's nice and shiny as we look around. It's just when we get to this section over here, this corner where this edge where we're missing pads, where we had that oxidation occurred, which means this was where the board had split obviously, and it had pulled with it those 5 pads. So let's go ahead and gently remove each one of those pads and take the iron to it. I'm going to try to do this without removing too much or any of that solder that's on there. There we go. That way we still don't have to do any reballing. We'll go grab this one. Just like that. And the last one. Now, if you really were in a pinch, you could actually salvage these pads. Instead of using the repair kit, you could just reuse those if you really wanted to. So now what I'm going to do is I'm going to go just up this side here, and we're just going to scrape a little bit at each one of these oxidized pads. I'm not trying to remove any material, I'm just removing the oxidation a little bit. Actually, I have something even better. So what I'm going to do to clean this up, instead of scraping at it, is first we're going to go around the border and just try to clean up the flux a little bit. This will also help a little bit with the oxidation, but mainly I'm just trying to clean up the flux. Hello.
It's me again, Derek. I couldn't get enough of you. Okay, thank you, Derek.
Yep.
Thank you.
Bye. Okay. All right. Now that that's dry, clean of flux, what I've got here is a microfiber brush, and what this will do is it'll remove the oxidation. So I'm just gonna take it and go over the pads, and it's just gonna slowly get them to the point where they're gonna receive some solder. Now it does leave a little bit of fibers here and there. Those just blow away really easily, but this is much quicker than trying to scrape each one, and we're not removing any of the solder. We're just getting rid of the oxidation layer, or at least breaking it up so that when the flux interacts with it, when the top board makes contact, the solder will eat through the remaining corrosion or oxidation and stick to and bond to the pads. So I'm just gonna do this all the way around the border a little bit. Anywhere I see a little bit of oxidation. Here's an example of an oxidized pad and what this will do to it. A little bit of scrubbing. You can see how already a bit shinier. Oh, in this area for sure. To the point where I'm starting to remove some of the layers there. I'm gonna go and make sure I don't do that anymore, but being a little aggressive there. And just blow away really quickly all of the fiberglass. Alright, now let's take a look again at our cured pads. Get that back into focus. Get out our scalpel. And what I'm going to do is just gently scrape at the top of this, and we're going to break up basically everywhere we need the pad to be exposed. And then you'll notice there's this orange covering to it. We're going to remove that as well. We're going to get down to the copper. You can see that nice and shiny copper. That's what we're looking for. And let's move on down to the next one. And down to the next one. And our last one. Now we'll take some isopropyl alcohol. And we'll clean up the area. Now the last thing you want to do in this area is float the CPU. That's why because we're right here, here's the CPU. Because we're right next to it, that's why I only go in with the soldering iron. So the last thing we need to do is just verify that we've got solid readings from each one of those pads. And yeah, 0.72, that's good. The next one we got right there, we are getting 0.305. So we've got, let's see, in the corner, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Yep, right on the money. And then we've got 1, 2, 3, 4. We should be reading 0.857. And we go in there, and I'm getting 0.86, 0.859. Yep, so that's right on the money. And then let's see. Then we got that corner. Should be open line. Let's see. So we've got an open line. Still says oh well. And then up here, we should be getting right here. We should be getting 0.304-ish. And we get 0.304. Alright, so we've got all of these joints perfect. We didn't mess with any of the solder. I'm going to go and clean up some of the oxidized pads here. And then let's get ready to assemble it. Alright, so now we have the pads off of the bottom. It's all cleaned up. All the oxidation that I wanted to remove is gone. And the top here, if you weren't looking too hard, you would never be able to see the 5 pads that I repaired. Look, Look close enough, you can kind of see them. So that's kind of what you're looking for. Now, because these both have a slight bow to them, we're not going to try to do anything fancy, try to bend them back. We're going to try to flow them back as they are. I do want to add flux to it. So we'll go ahead and insert that in here. Okay. And I'm going to go around gently and put on a little bit of flux around the border. And then when we match up the top board, the amount of flux that I'm using is a little bit more than is needed, which is okay. Especially in this oxidized area, even though it's really not as oxidized as it was before. So there we go. We'll take our top board, and if you really wanted to, you could remove this, but because we have these clamping features, I'm not going to remove any of the thermal paste that's in there. We're just going to let the compression work for us. Because I didn't reball it, because of the bend, like there's plenty of reasons why not to reball this particular scenario. If the board was flat, I'd reball this in a heartbeat. I wouldn't use the pressure clamps because then I wouldn't have the spacers, and I would just let gravity do its work. But in this case, because of the way that it's bent, I will be using, and because I intended on not reballing it, we will be putting pressure on it. I'll line this guy up, give it a little bit of like a circular massage, really just get that flux to coat the top board too. Get this lined up. I'm going to put the clamp on here. We can get a little bit of pressure on there. We're going to double check our alignment before starting it up, but then we'll start it up. Alright, I like what I see, so we're going to go ahead and turn it back on. Let this get up to 250 degrees Celsius. We'll let it go for the full 2 minutes. I'm just going to be watching it, babying it along the way. We should get it to settle, all the solder joints stick. We'll let it cool down all the way, and then we can test it. Alright, we're almost up to temperature. Alright, we're at temperature now. And we've got our time going down. Giving it a little nudge here and there. Down a minute to go. And we'll let this cool all the way down. I took the pressure off because I felt like it was lifting this one side too much. So once I took that off, the other side kind of settled back down in a little bit. And then I saw it kind of snap down when I gave it a nudge on this side. So hopefully we're good. We'll take it under a microscope, really look at the border, make sure we're solid. We'll plug it in and we'll test it once it cools all the way down. Cool it down quicker, I'm going to put it under. Alright, let's go take a look under the microscope at the border. Alright, so taking a look here at the border, you can see that gap is nice and closed all the way around. If that looks really good. Solid. It's a little tall on this side, too tall. Yep, and it's not all the way down on this side. You can see that gap there. You see how they kind of stretch right here. We need to go put it back on and get this side down. Alright, after the second time, let's see how it looks. That is much better. Yes, that's good. There is, I can see the joints, but they're not stretched at all. Like they were on this corner. They used to be stretched, now they're down. Let's just make sure nothing else lifted at the same time. That looks nice and solid. You can see it does get a little bit thick. It does get a little bit more swollen here, but those are all making solid connection. Like if we zoom down and in there, you can see even though they're not as pancaked, there is solder touching on all of the joints. See, these are more pancake, or you can almost see them disappear, like they're all gone here. That's what you normally would want to see. But these are all looking really good. All the way down the side. Let's flip it over. Solid. That looks solid, 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 solid. That's good. Yeah, it's a little expanded here, but it is making contact. It's like right at the edge of where I would start to get uncomfortable right there, but it should be fine. So, yeah, that looks really good. Given how bent this was, this is I am perfectly okay with the amount that this is touching. Alright, let's go test it. Alright. Got a good feeling about it, so let's go ahead and put these stickers back. Put that sticker back. And we'll put the last sticker back. Okay, let's get it installed back inside the frame. These little two flexes kind of get in the way. There we go. Now obviously I'm not going to crunch down on this because we have the broken back, which means we've got a weak frame, so we can't push against it. There's going to be no pushback on it, so we don't want to snap the board. I'm just going to gently make sure all of these get connected without pushing as hard as I would otherwise. Because now this board is slightly compromised because it already had the damage done to it once. It's more prone to having it done again. I'll reconnect up the 5G antenna. Put the battery in. Connect up the old screen with the proximity sensor because I haven't bothered to transfer it yet. We'll connect up the display. And we'll connect the battery. And fingers crossed it turns on. Got an Apple logo, that's good. Now I could have used a power supply to test, but I'm confident in that, so we're gonna go ahead and just turn it all the way on with it all the way fully installed. So, all right, we're searching up the top. Oh, look at that, and we've got service. So, all right, we definitely have 5G service. Really don't get good service here in this room, but. And we have obviously our Wi-Fi still, and Bluetooth devices. I don't think there's anything around me right now that wants to be paired. Yeah, this is all good to go. So there we go, an iPhone 12 that was severely broken to the point where it caused board damage. Luckily, this one was only 5 pads that I had to fix. Now, I highly recommend anytime you split a board to reball them before putting them back together. If you'd like to see a tutorial for tips and tricks on how to reball the sandwich boards, leave it in the comments below. Judging by the way that this board was bent, the judgment call to not reball it and to avoid messing with the solder in general, I think was the right call. Like the video if you learned something, subscribe for more future videos like this. Thanks a ton for watching. We'll see you in the next video.